guess I'm ready to go. Is everybody ready?
We should be ready to go anytime.
Okay, welcome to our weather discussion today. We have finally had a rain event. This was the first rain event in 12 days, which, you know, I don't know if you keep track of it. I don't particularly, but this year I have. All the way through the first half of August, the longest stretch we had without any rain, including a trace, was 5 days. And that was in mid-May. We had a 5-day period where it didn't rain. And then, as you know, May, June, and July were quite wet overall. We were, in fact, something like 8 or 9 inches above normal for those 3 months, but all added together. And then we just went through a 12-day period without any rain, and it ended last night. And that, I think, is the longest one for the season. And we ended up at the airport with 0.67 inches of rain, and that puts us only 1.51 inches below normal for the month of September. We were 1.24 below in August, and so it's been a really Jekyll and Hyde warm season. May, June, July were wet, then August and September are exceptionally dry. Not record-setting dry, but just a big change. But Pete mentioned this too, that this morning's dew point after the rain last night was 66 at 10 a.m. And I couldn't find a way to determine what was the highest dew point in the latest date of the year. I can't seem to figure out how to do that on this nifty website I have. I'm going to have to investigate some more. But that might be rivaling. We might be getting close by getting nearly a 70-degree dew point on the 20th day of September. That's pretty unusual. Of course, the equinox is on Sunday. I think it's in the morning. Isn't it like 7:30 or something like that? So that's coming up. But I just wanted to tell you a couple of other things. I heard some people mentioning, because I agree with them, I'm tired of the 80 degrees. We've had 10 straight days with highs at 80 or above. Do you know what the all-time streak in the month of September is for Madison? 11. And it's 1971 and 1978. Yesterday was our 10th. Today will be our 11th. And Saturday will be our 12th. We are likely to set an all-time record for the most consecutive days in the month of September with temperatures 80 or above. So we're living through history, which is kind of cool, I think.
It's like Phoenix in their 100 degrees. Didn't they have like 100?
In the 120s or 130s, yeah. I don't know.
They finally had a high of like 93.
Did it finally break?
Yeah, they stopped the over 100 degrees.
Yeah, that's amazing. And it's completely unprecedented. And I think it's been treated in the news as just a curiosity, but not as sort of very often anyway, not as an unprecedented curiosity. It should have probably been emphasized in that way. So anyway, we're about to set that record, it looks like, tomorrow. So we have to be rooting for one more 80 after today to just break the record. Then after that, I think I heard Jenna say it's going to be a lot cooler next week, which is true. And there'll be we're going to do a couple of things here in the morning. In this discussion, I mean, we'll try and discuss where did our rain event come from. It's rare. We've only had 3 days in the month of September where it's rained. The other 2 were 100th of an inch, and this was 0.67. So where did it come from? And it looks like almost an exact repeat of this goes on Saturday night into Sunday morning. And I'll show you why I say that when we go through some of the analyses on the map. Then we'll turn to the forecast, where the forecast has some kind of interesting things, not so much for us. It's going to be a nice week next week, it looks like, so that's nice. But a week or so from now, it looks like there may be a tropical storm crossing over onto United States soil. That one, I think, will be the panhandle of Florida and Alabama. And then a week after that, in the forecast, a more substantial storm hitting a more populated area, Dade County and parts of east coastal Florida. So that's not something to be excited about. And then after we deal with the tropics in the forecast, we'll meander to the Aleutian Islands, where a week from today, that's going to be what we talk about in our weather discussion. Right now in the forecast, there's a cyclone for Sunday morning, I think, next week, 933 millibar low, right at about Dutch Harbor, Alaska. That's a beast. And so it's going to be fun to look at that in the very far forecast future, and then next week in the near-term forecast future, if it still exists there. And I will point this out. I was alerted to the presence of this beast in the forecast by none other than Professor Michael Morgan, the current Undersecretary of Commerce, serving in NOAA. Now, those of you who know our long-standing dispute about which storms are more impressive, tropical or extratropical, will understand that this is a historic moment, because he wrote to me this morning and said, look at this thing at 10 days or 11 days, maybe it's 11 days. Look at this thing at about 10 days. And I said, what in the world are you telling me about this? This is ammunition for my winning this long-standing argument. And he says, well, how do you know it doesn't have a tropical origin? Now, I know it has no tropical origin, so we'll prove that today. I know he's not listening. He may watch online, but the fact is, he just he threw me the biggest bone of our argument for the last 30 years, and I, of course, win. I've always been right, Pete knows it, and most people who attend most of our discussions know that. But today, Michael pretty much conceded. So I'll show you that as the last part of the discussion. But let's take a look at this animation. On about the 5th day of this animation, you're going to, first of all, very active over the continental United States, especially beginning about the 14th of September, or 15th, right here. Here comes wave number 1. There's a nice development across the Central Plains. This thing here on the 16th, 17th, and 18th is more impressive. This is a rare development over Wyoming and Montana. And we talked about this in 452. It's not that they never happen there, it's just nowhere near what you'd call a traditional place for a major cyclone development. But nonetheless, that's what happened. Most of it, rather shown dramatically in the satellite depiction of it, it's not very dramatic as a sea level pressure minimum. And so we may visit that, we may not. We did during the week. But it certainly is the feature that had our address in mind. So that was storm number 1, and then a second convective line developed, and that's what got us last night. So we'll take a look at that as a diagnosis of what we saw over us last night. And we'll begin, I guess, doing that by looking at a series of upper level charts. So can we go from there, Pete, to go to the 500 millibar super, Pete? And so this is this morning's 500 millibar map at 7 a.m. And so there's a trough axis that's just passed us by 7 a.m. Of course, the precipitation was largely done by then as well. The wind is out of the southwest at Green Bay, out of the west near Moline and places like that. So it's westerly to southwesterly, and then you can see flow goes straight northward toward Hudson Bay. So there's a pretty nice trough axis right in that location. And downstream of the trough axis is a preferred region for ascent. But it doesn't necessarily produce linear ascent, the kind that's a squall line like. We have to add some other detail to that to really know why it was linear. But certainly the environment encouraged ascent at times, probably hours before 7 a.m. And I think if we can go back maybe one map, we'll see the 0Z analysis. We probably should have the movie ready anyway, because I'll talk about that. I guess I should have said that. So here's last night at 7 p.m., and that is when the trough axis is just to our west. So we were just getting ourselves into the region that's favorable for ascent. And the precipitation came around 10 o'clock. So it was just after this. We had a nice discussion in class yesterday about this exact event, and everything that Ben and Logan said pretty much came to fruition. So that was a pretty nice discussion. So that's one upper level feature, and then there's another one off the California coast. And then there's a broad region. It doesn't look like it because of the map projection, but this is a latitude line here in the western provinces of Canada. So this flow here is more or less zonal, just east-west. And embedded within it, there are a couple of little short waves. There's one off the Aleutian Islands, and there's one here right off the so-called Queen Charlotte Islands off the coast of British Columbia. So that's the one that we have to worry about for Sunday, Saturday night, Sunday. This was the one we worried about for Thursday night, Friday, and they have very similar evolutions, as it turns out. I guess we're not going to look at the evolution of this one, but we will watch this one in the forecast panel. So it doesn't look like very much of a perturbation in the geopotential height lines, but notice it's a concentrated region of horizontal shear. Upstream there's a bit of a ridge, downstream there's a bit of a ridge, and so it's right here, right off the coast of British Columbia that feature resides right now. Largely invisible to any sensible weather, but when it develops a little further, it's going to be able to spawn some more convective activity, I think. And I think one of the other setup reasons to think about is this disturbance is already, we saw at 12Z. Let's go to 12Z, Pete. Sorry. Go ahead one time. So here you can see a little bit more southeastward progression of that disturbance in British Columbia. It used to be at about the mid-coast, and now it's kind of in the southeast part of the province. So it's on its way, and the wave that spawned our precipitation overnight, importantly, the axis is now to our north and east, and we still have this cutoff feature over Southern California, and the big ridge sitting over northern Mexico and Texas. And I think one of the reasons I'm concerned, not concerned, one of the reasons I'm thinking that the arrival of this wave will be met with rather similar environmental conditions is there's no particular reason for the air to get drier or colder between now, where we have a zonal flow at 500 millibars, and a southwesterly flow to our south, and Saturday night, Sunday. So all we need is another agent to produce lifting in the same kind of environment, dew points in the 60-ish range, it's going to be easy to spawn a next wave of precipitation. So that's the broad characteristics that I see as I look at this map, and these two in a progression. Okay, so we'll take this up in the forecast a little bit later. Let's take a look at the same couple of maps at 300 millibars. So this is last night at 300. We were nowhere near any particularly strong jet. The flow is really weak, 35 knots at Green Bay, 55 in Western Ontario, only 50 at International Falls. The really strong feature of interest is this jet streak, which is more or less straight along the Alaska and then British Columbia coast. And in this particular spot, of course, there's a speed decrease, so there's a deceleration back toward the jet. And if you figure out the cross product of the acceleration vector, you're going to have an ageostrophic wind pointed southwestward off the coast of Washington. There'll be upper convergence of it there and upper divergence of it here on the border of Alberta and British Columbia. And that's where we saw a little bit more of the development. You'll see this little bit of a height trough is going to get more exaggerated in that location at the next time. Because why? If the air is being forced to rise, then it's cooling by expansion, and the thickness between 1,000 and 300 millibars is going to go down when the air gets colder, and so the 300 millibar height has to get lower, right? So that's one of the ways in which a jet oriented on the western side of an upper trough tends to make the trough get a little more intense. Let's see if that in fact turns out to be the case. Yeah, that's a little bit sharper trough. The jet's got a little bit stronger too, but the trough's a little bit more curvy than it was before. So we're seeing that play out the way that one might expect. And so the upper vortex structure associated with this disturbance is a little more potent than it was 12 hours ago, and it's closer to us. So that's the feature that's going to make our weather change again Saturday night into Sunday, and we'll look at that in the forecast. Okay, let's see. Let's take a look at a couple of other things. First, let's take a look at the visible satellite image over us just for the last several hours, if we could. And so here it is. As I said, we're tracing a feature in the upper levels over British Columbia. You don't see anything associated with it particularly. Maybe these clouds in southern Alberta have something to do with the wave as it's beginning to develop. They'll get a little bit more obvious as time goes forward through the day today and into the day during tomorrow. But broadly speaking, over the continental United States, it's pretty much cloud-free everywhere. That's really something, isn't it? I mean, it's really pretty amazing day across much of the country, and you can see the daytime heating is spawning these low-level stratocumulus clouds over a broad region of all the way along the Gulf Coast and then up the Atlantic coast, at least to the mid-Atlantic, in the face of probably high dew points, we'll check in a minute, and daytime heating unimpeded by large synoptic scale sort of cloud decks that might filter it out. So, and then we've got the remnants of a couple of weak tropical disturbances that are spawning, that are still cloud containing over parts of southern New England. So I don't think it's heavy rain there today, but it certainly was a little bit heavier yesterday. Largely speaking, the Atlantic Basin is inactive. We'll take a look at that from the National Hurricane Center perspective in just a minute. Incidentally, the exact same thing about these daytime clouds building up in the daytime heating is true over all of the northern part of South America, the part we can see on the satellite image. So this is a widespread phenomenon, as you can see. Okay, let's take a look at our radar depiction, our mosaic across the country next, Pete. So they've got all their radars turned up to high sensitivity here, I think that's what that is.
I think it's super reflection. When you get an inversion, it bends the beam and you end up reflecting off the ground rather than going through there.
Oh, okay.
I've got a webpage that explains that. People call me or contact me all the time about like the spikes, like they think there's some conspiracy that.
Oh, that's just the sun. Right.
Well, sometimes it's the sun, sometimes it's cell towers do that. One up off of
this one here.
going southeast, that's been there for years.
Okay.
It's some cell tower or some sort of radiation emitting source that is in the same frequency as the radars. So it's normal,
Yeah.
it's not anything crazy. But of that bloom that you see in the southeast, typically you see that in the spring and the fall when it gets kind of cool and an inversion at night and a moist boundary layer.
Yeah.
I don't
I'm
know if it's
confused
dust
about
or
how you get
exactly
stratocumulus to develop if the boundary layer is so stable. That's the thing that doesn't make sense to me. But yeah, you might see on days where it's widely clear like it is today, sometimes you'll see at each of the radar stations a little, at certain times of day, a little beam that gets lit up, and that's the sun. So the sun is sending all kinds of radiation. Some of it happens to be the 10-centimeter radar
Yeah,
radiation.
right at sunrise and sunset,
Yeah.
you'll see them go zipping across the country.
Yeah, you can see it go across the country, it's pretty neat. So here's a fairly stationary band of precipitation over the eastern counties of Massachusetts. It's barely making its way into my hometown, which is right there, but very slow progress. One gets the impression that the whole disturbance is about to move off the coast, and in fact already begins to look like it is on the broader picture. So that might be the farthest west that this precipitation gets up in New England. And then some weak echo across Kansas and parts of Missouri. Little bit of interesting, maybe convective features up in northeastern New Mexico, a nice line just across the desert in Southern California. That's kind of interesting. And then some scattered convective elements over the Bahamas and off the coast of Florida. That's really about it. Some of what remains perhaps of what came through us from 2 to about 6 a.m. is right across the state of Michigan, and maybe it's kind of flared up here over far southwestern Michigan, just as it's coming out of Chicago. So that's interesting. But that's about it for precipitation across the country as determined by the radar. Let's, can we take a look at the cold pool map that I pulled up on my mail? I want to show you that. So here we are. I think I mentioned this a couple of weeks ago. I missed last week's discussion. I was out of town, but now I'm back, and this is, there it is. This is this year's trace of the 850 millibar -5 or colder air over the whole northern hemisphere. Okay, so, and I'll remind you, I got to take these off and update them. These are last year's record-setting, new record-setting days. But otherwise, the gray bars indicate the maximum aerial extent of all time in a 76-year time series now, or the minimum in a 76-year time series. And then these other colors are either on the longer ago average, maybe the current climate average, and then the long-term 76-year time average. They're all about the same, as you can see. But our current time series is way below the average for the current set of days, 1st to the 19th of September. And it turns out this is the 8th warmest, 1st to the 19th of September in that 76-year data set. And this is the whole northern hemisphere now. So we're off to a relatively warm start for the cold season. But 8th out of 76 puts you at like the 89.5 percentile. So I don't care about that. I'm thinking 90 plus is what I get interested in. So we're not quite there. But it's interesting. And the dichotomy between local, regional weather and hemispheric weather measured this way is often jarring. And so we may find a period of time in the wintertime where we're bitterly cold, but the hemisphere on average is warmer than it usually is on that same day. And that's kind of fun. It doesn't seem to happen too often at this time of year. So that's the cold pool situation. Can we take a look at the National Hurricane Center page, particularly for the Atlantic Basin? It'll kind of feed into a point that I think I'm going to make next when we move toward the forecast now. So we're looking again at a couple of disturbances in the Atlantic that maybe have a less than 40% probability. They're both at 20% probability of turning into a tropical cyclone in the next 2 days. So it's been a really inactive Atlantic season thus far. And of course, the predictions were for a very hyperactive season, and so there's a big disjuncture there. And people will be interested in trying to figure out why the prediction was so bad compared to how things have gone through this point. And we're now about a week past the peak of the Atlantic hurricane season. If you take all of the Atlantic storms that have ever occurred and put them on a time series, they peak at September 12th. That's the most common day for tropical cyclone of any level of intensity in the Atlantic Basin, and we're about a week past that. And I think when you get to the end of October, which is now only 6 weeks away, you are pretty much done with the season. You might get a few Category 1 storms that then turn into extratropical storms. They can still be impactful, but they tend to be clustered in the basin. They don't make landfall as frequently, so everything starts to change rather dramatically, beginning around now, and then continuing in that direction to the end of the month of October. So kind of an interesting lack of activity that I think we may talk about for years to come, trying to figure out what it was that's doing that. Okay.
We have a call-in from Michael.
Ah.
I told him that you were claiming victory in the ongoing mid-latitude versus tropical debate. He said, yes, please inform the Weather Watch participants that I concede nothing.
Well, that's okay. We're in an era where people who lose don't concede. I don't worry about that. You know, we're all used to that. So we're all used to that. We can deal with it. So, yeah. I just want him to show me what's happening in the Atlantic, and maybe he could comment on the lack of tropical origin of our beast that we're about to be introduced to, so that'll be fun to talk about. But I'm glad he says he concedes nothing, because we have to keep this going. So I guess now we'll turn to the forecast. And let's begin with a forecast for our own region of the globe, so that we'll do that first. And maybe we'll start at 500 millibars at, I want to make this smart choice here. This is the 12Z run?
Should be, yeah.
Okay, so then let's look at 0-hour forecast, so that we look at this morning's analysis.
It's saying only 3 hours, done through 3 hours. I don't know what's going on with that.
Oh, we can do the 60 then, it doesn't matter. And then let's look at
That one didn't
the
finish
6-hour
either. I'm
forecast.
not sure what's going on with that, but we'll look at the close.
Not the surface, let's go to 500 millibars. So this is the 6-hour forecast that depicts the same set of observations that we saw at 500 millibars for 12Z this morning. And so, not surprisingly, all the features of interest are in the same locations. There's an upper level cutoff feature at 500 millibars right off the south, right near San Diego. And then there's a feature that's to our north and west, and that's the wave to which our precipitation band that came through last night is tied eventually. And then here's the one that I was mentioning over southern British Columbia that probably bears down on us for our weather into Saturday night and Sunday. So that's the trio of disturbances in our near vicinity or having a substantial influence on our flow. And here's the great red spot over Mexico and Texas. That's a big anticyclone that has been really hard to dislodge. And even though there's now going to be maybe more frequent passage of extratropical and high latitude disturbances across its crest, it's still going to take a while for that thing to go away. And as long as the foundation remains, there's probably opportunities for some more, maybe 1 or 2 more of these periods of time where we have temperatures over 80. But I think we won't see another 12 straight days at 80, I don't think, anymore this season. So this is the beginning of the end for this massive continental ridge, I think. Okay, so that's the feature of interest. I suspect will have more of an impact on our weather than anything else. This one will keep us in southwesterly flow, which will maintain our shot at 12 straight days at 80 hot or higher. So let's take a look at the 850 millibar map at the same time, just so we get a sense of where everything is in terms of the lower troposphere. So there's the cyclone tied to the most eastern wave that we saw, the one that's on the southwest coast sort of Hudson Bay. Here's a geopotential height trough. It's not really frontal in nature, or not strongly so, but there is a little bit of a baroclinic zone. It's cold in the light olive temperatures. That's about +6 at 850, and then when you get down to where we are, we're in this orange, which is more like +20 or +18. So about a 12-degree temperature contrast within, here's a geopotential height trough, and the baroclinic zone is in there. It's just not as dramatic as you sometimes see, but it is there. And that was the feature that I think had something to do with producing a linear band of convection instead of just a blob in the region downstream of the trough, and for reasons that we'll talk about later on. But it has to do with something called frontogenesis. So I think that's probably what's going on along that line. But it's a weak disturbance, and you don't see hardly any manifestation in the lower tropospheric heights of the next upstream disturbance. Perhaps this little bit of a troughlette here over northern Glacier National Park and parts of Saskatchewan. That is probably tied to the presence of that upper wave. But that will be the thing that develops a little bit more intensely. We see almost no lower tropospheric reflection of the upper wave over Southern California. I say almost no because there is a broad region of low geopotential heights, but over a mountainous region, it's really difficult to know what's that's all about. But very warm air in the central part of the plains with a low here that keeps us in southwesterly flow in the lower troposphere, which I think gives us a good shot at breaking the all-time record for September, number of days over 80. And then I haven't mentioned it again since the first part of the discussion, but we had that broad zonal flow at 500 millibars. Pretty tight geopotential height gradient, strong wind speeds. Should have looked at the jet, but we won't go back now. But right along that region of strong upper tropospheric flow, not surprisingly, a very strong baroclinic zone. And that has to be true by the thermal wind. You can't have this strong temperature contrast over this kind of a broad synoptic scale area without it being reflected in the vertical shear of the geostrophic wind. So the maximum winds are strong over that region because of the presence of this temperature contrast. And the jet itself and the little waves along it can spawn these little cyclones. This is the one we mentioned a little bit in the second half of the discussion yesterday at 452. It's not really tied to a jet entrance or exit circulation. It's instead a little bit downstream of an upper wave, but it's in a perfect position to start developing And then there's another one almost at the end of the Aleutian chain that's pretty intense as well. And there's one more further upstream if you look at a bigger scale model, domain. So the Pacific Basin is active, and we'll see that when we look in the forecast out in this region. Pacific Basin cyclone activity is revving up this week. It's going to be really fun. Meanwhile, Atlantic Basin, even extratropical Atlantic Basin cyclone activity at a minimum. So really asymmetric across the continent. The west side is wild, the east side is kind of boring. What it looks like right now. Okay, let's go to 6 hours into the forecast. We haven't, we are, no, 12 hours.
6, yeah.
Yeah, let's go
12
to
would be
12.
about now.
Yeah, 12 will be about now. And so there's our wave of interest, and it's just about to cross the border from Canada into far northwestern Montana. And this one's moving further away, and you can see the trough axis is further away now than it was at 7 a.m. That's not surprising. So let's go at 500 millibars only, 6 more hours ahead, Pete, and watch how that thing marches across. Here it comes, kind of falling apart a little bit, but the wave, the geopotential, the curvature in the geopotential is not falling apart. And now the trough axis is maybe over far eastern Montana. And getting closer and closer. Let's keep going. And this gets us to, tonight. Here it comes. There's the trough axis over western North Dakota. And we're right there, so we're getting closer and closer. Go again, if we could. So by the time we get to tomorrow morning, we've got this wave poised just to our north and west. There's another one that looks rather like it upstream over the islands. There's yet another and another one. So it's active, lots of them. But this is the leading one. And I think we'll just jump to 12 hours from here, which will be Saturday night. Yeah, Saturday night. Here's the wave, and boy, does that look a lot like what we had last night. We didn't have this wave axis right over Wisconsin. It was a little bit displaced to the north and west. This one maybe even a little further to the north and west than the one last night, but otherwise a fairly similar setup with, potential for ascent over much of Ontario and in that province. And then I'm guessing, we'll look at 850, I think there'll be another trailing baroclinic zone along here, which probably provides us the threat of similar kind of precipitation around this time tomorrow night. So let's go to 850.
Same time?
Yeah, same time. Thanks. This time, the baroclinic zone's a little bit more obvious to see, isn't it? Look at that contrast in temperature. And Jenna, this is kind of in line with what you're thinking. I think once this whole wave and frontal zone complex goes by, it's a little bit more of an open floodgates for chillier air. Fine, you're not going to be in the 80s. But here's the baroclinic zone. It has strong temperature advection, cold air advection on the backside of it. You can see the arrows are pointing across the isotherms from cold to warm. And then right up in our region, about 7 p.m. tomorrow night, the winds are more or less parallel to that boundary. And so you end up piling up the isotherms in the horizontal. And if you do that, you change the thermal wind, you make it stronger. And the thermal wind acceleration is going to have implications for developing a circulation, namely a thermally direct circulation where the warm air is going to rise, the cold air is going to sink. So we are in line again for the same type of weather we had last night. For this reason, for the passage of this disturbance. Can we go to the 42-hour forecast of the lifted index panel, please? This is going to give us a measure of how resistant is the air to moving in the vertical. So where you have the dark shading, this variable called the lifted index is negative. And that's a measure of how the temperature of a displaced air parcel compares to the temperature of the environment at 500 millibars. And if it's warmer than the environment, then the index is negative. And that's what all this shading is. So everywhere in the tropics usually have such a characteristic. But here's the last bit of what used to be a flood of that air coming straight up through the central part of the U.S. The last bit of it right over Wisconsin at precisely the same time that we have this frontal passage and the frontogenetical forcing associated with it. So that's why I say tomorrow night may be a replay of last night, in the sense that we have both forced ascent, not diagnosed by this chart, but by the prior one, and not well stratified air that's going to be forced to rise. And so it's going to be easy to get some free convection. More bang for your buck. Some of the air will just go up because it's made positively buoyant, and it'll just keep going up on its own once you start pushing it up under these conditions. So I wouldn't be surprised if we see something similar to what we had late last night, maybe a little bit earlier tomorrow than it had happened on Thursday night, but that's, I think, in the offing for us. But then, if we can go back to 850, let's go a whole day beyond that time, which was 42, I think, so anything in the 66 range or something like that. Here's the cyclone that's tied to the wave that's well up north now on the southwest shore of Hudson Bay. And this is much chillier air than we've seen in 2 weeks. And it's already infiltrated into Wisconsin. We're back behind the leading edge of that cold air. And so we're into the plus 6, plus 8 degrees at 850. That's a big change, a very comfortable change for us. It won't only be cooler, but it'll be drier. I mean, the dew points will go back into the 40s probably, because this is Canadian air. Where did it come from? It came from the archipelago, so there's not a lot of water vapor in the air up here. And so it's on its way, slowly infiltrating into our part of the world. Notice how active things continue to be in that broad baroclinic or strong jet structure off the Pacific coast. This is a really strong storm early in the week at sort of Dutch Harbor, Alaska. We'll go to the sea level pressure analysis for this time, just to see what it says at 66 hours. Yeah, 969, that's really intense. Okay, so this is a really beastly storm. It's nothing like what I'm about to show you. 969. And there's the rain going through late in the day on Sunday into, late in the day Sunday. It's on its way out. And the lower thicknesses means cooler temperatures. So first, before we look at the beast, the weekend, I think, looks like this. We break the record for all-time consecutive days at 80 plus for Madison. That in September, that's awesome. That was an unexpected little nugget that I found this morning. We have another rain event Saturday night to Sunday that has many of the characteristics of the one we just had. The differences between last night's and tomorrow night's, I think, is that the forcing for the ascent will be stronger. The baroclinic zone is stronger. And the air is just about as poorly stratified as it was last night. So the combination is going to be, maybe we'll get a little bit more interesting thunder, even though it was, as Pete said, interesting to hear thunder again for the first time in a couple of weeks. I'm not going to go through the whole forecast over the region into the future, but this will be the last precipitation event we have for probably another 2 weeks, which is amazing. It looks like we're going to enter another prolonged dry period, but this time cooler and probably drier dew point wise. So we won't have any of these challenging, uncomfortable days. That's what it looks like to me.
So Michael's eating a late lunch and he's joined us. He says 969 ho-hum.
Ho-hum. What Atlantic storm has gotten to 969 this year? Tell me. Michael? Tell me which one.
On the clock.
Tell me which one. And then tell me which one got 36 millibars deeper than that. So now let's go to pivotal. I think it's pivotal. Whatever one you can kind of easily page through. I think it's tropical, actually. Tropical tidbits is better for this. Yeah, I don't like having to use that thing. Right here, Pete. And then let's go to forecast models and regions. We're going to go North Pacific. And that is, where is it? How is it? There it is. Perfect. Okay. And then, so first of all, sea level pressure in black. The red lines are 1,500 thickness until they get to 540 decameters, and then they turn blue. So that's traditionally the rain-snow boundary. That's the 50-50 rain-snow boundary in only half of the continental United States locations. Never use that with any confidence, okay? -5 at 850 is much better. 0 at 850 can get you a snowstorm once in a while, but -5 is a guarantee. So anyway, this is not such a great thing, but it's nice that it's different color. I'm not complaining about how it's portrayed. Very active, storm 1, 2, 3, 4. Look at that. And they're all fairly intense little beasts, right? And that's current. So let's just march through this. And there's nothing tropical that's organized down here on the southern side of the anticyclone. Let's just keep going. That one turns out to be pretty good, but it never gets fully wrapped up. Watch how this doesn't really get wrapped up. Just can't do it. That's an interesting question all by itself. There's no particularly wrapped in thermal ridge. It's not deeply occluded. How come? I don't know off the top of my head, but we're working on that problem. So that one's pretty strong, 971. What Atlantic hurricane's got into that? I don't think there is one this year. 997 off the coast of Japan comes the next one. So that one's a beast, but not really that intense. This one also really seems to be struggling to shed the stretching that's provided by the jet. And it can't really wrap up. Let's keep on going, Pete, thanks. Incidentally, anticyclones are always in between these. So that storm just doesn't really get anywhere. There's the next one. Still, we saw nothing from the tropics. Oh, wait a minute, 979, 972, okay? 958, 953, these are every 6 hours. 950, 949, 950 again. What happened here? A better forecast earlier. 957, so that's the same time. So already this forecast has changed. Let's go back to 0Z at the same time. Watch this. Already it's changed, but it's still more intense than anything we've seen in the hurricane season. 935. So this is, and it's a week plus away. So this is something to watch. That's where I got the 933 that prior time. And that was the 60 run, I think, from last night. So this storm has already got a huge divergence of solutions in a very short time. Eleanor?
Is that 24 hour, like it's like 20 and 24, that's explosives type of thing?
Oh, this one goes down in this forecast. This one went down, I have it written down, 46 millibars in 24 hours. So it's a beast. You know, I mean, this doesn't happen more than twice a season if we're lucky. But also, look at the beautiful structure. The green, I should have said, is forecasted precipitation. But look at the intense horizontal pressure gradient force. They draw them every 2 millibars. That makes it look more dramatic. But then the thickness gradient is really concentrated and then abruptly stops being concentrated right at the pressure trough. Why? Because this is the cold front with baroclinicity. And then this is the broad warm sector. Look at how uniform and how widespread that area is with the same thickness. And then here's the stubby little warm front where it's more or less uniform warm advection. Interesting, that's why it's not precipitating. That doesn't produce vertical motion. And then right here in the wrapped up, you can't see it as well as I can, beautiful wrapped up thermal ridge. This storm in this forecast is deeply included. And now, just to remind ourselves, let's go to the 6 hour forecast. What did it look like then? It was still pretty intense and roughly the same structure, but now, the more recent forecast has a very different structure. The cyclone center is quite far divorced from the peak of the warm sector. The warm sector is kind of not so obviously occluded. It's suffering the same fate as the storms we saw preceding it in this week-long forecast across the Pacific. But it doesn't dispel the fact that the Pacific storm track is really active right now. And we're seeing some really intense developments. And this one is now, it's 24 millibars different between the 0Z forecast and the 12Z forecast. 24 millibars a week. That's interesting. How can that not be of interest? And then we don't know what will happen as we move forward into more forecast times. Does something get better resolved by satellite or by some observations off the coast of Asia that makes this thing either continue down this path, which is still intense but not as intense, or does it flip back to 933? I don't know. It's going to be fun to watch. No matter what, we'll talk about this thing next weekend.
Michael said Burl got down as low as 965. You were asking to
Oh.
find below what is
Okay,
967.
965. Okay, so you wait a
He's got
whole
it.
season. So let me get this straight. You wait an entire season, put all your eggs in one basket, and you hope that you get down to 965. I can do that without even thinking. I can do that with a disappointingly weak forecast. So,
He says, nice cyclone in the Pacific. What about the Gulf of Mexico?
yeah, I'm gonna go there. Don't worry, I'm gonna go there. But look at the extent, now that he's brought it up.
Okay.
Let's just look at the extent of this thing. Let's go to another variable, lower dynamics. And we can look at 850 millibar height and wind. So these are the 850 millibar winds associated with shaded in. So when you get into the purples, these are in meters per second. And so, no, not, sorry. So the first couple of purples are outside of the hurricane range, but the deeper purples are in it. So there is some hurricane force winds around the periphery of this storm, and there's certainly tropical storm force winds over an enormous area. Let's just project that area onto the southeast United States. Oh man, I guess that would take up all of the southeastern United States would be under tropical storm winds instead of this little bit right here.
There is a little bit of projection stuff on there though too, because for this
Well,
projection,
that's true. That's
I mean,
true.
Alaska is not that big.
That's true, but it's not the same thing.
He says
So-
uncle.
What? You said what?
He says uncle.
Yeah, he always does when I get to the circulation.
It sounds like you're on the winning side, John, I think.
Yeah,
I don't know.
I think I prepared. I got my talking points. He can't beat me today. But let's go back to the sea level pressure because that was the last thing I did want to talk about. And we'll go all the way to the beginning of the forecast peak and just watch the Gulf Coast. Okay, and it's two different storms that we'll see. Okay, so we can stop there and then stop going forward. So you're going to see one come off sort of the Yucatan in between Cuba and the Yucatan. That's this one right here. And that storm in the forecast, this is getting to like a week from now, is bearing down on the panhandle of Florida and southern Alabama. And that's not changed from the 0Z forecast, although it's more intense in this forecast. Let's just show that. 0Z forecast, I think, was much weaker for that storm. Yeah, much weaker. So that's a more substantial event. I had it in my notes the opposite way, that the first one wasn't so substantial. This is a really impactful storm. And so maybe the lesser populated part of Florida, that's good, but it's not far from New Orleans. If it has a little bit of a western turn, it's right over New Orleans. Let's keep going. There'll be a second storm. This one is going to have some impact over the southeast in terms of precipitation as well, actually south central states. So here comes another one. I think it develops right in about the same area, at least it did in the 0Z forecast. Yeah, here it comes off the Caribbean. Maybe. No, I guess there's only one storm now. That's it. This time, the second storm is weaker. That was the one that was down into the 960s. Show that, the 0Z forecast. Yeah, keep going forward on this one. Yeah, that's in the 970s. That's an intense hurricane right over Dade County. And so, very different solutions. The first one in western Florida now is stronger, and the one in southern and eastern Florida is weaker in the current forecast. So again, bears watching. We have to understand, we have to kind of keep our eye on that thing. It's going to be one after another. They're separated by a week still in both forecasts. So it's going to be 2 weekends in a row for parts of Florida and the eastern Gulf Coast of the United States, it looks like.
That's the 6Z run Michael wanted to check out. 6Z.
937, look at that.
What about the one on the Gulf?
Yeah, that's the stronger of the two in both the 6 and the 12Z forecast run. And that's New Orleans, right over New Orleans in the 6Z run, 0Z run. I mean 6. So, interesting. And look at the parade of cyclones continues. We're well towards it, we're past the beast, but we have a parade of cyclones along the Pacific storm track, so it's going to be really active. But that's all I have. Are there any questions or comments, Eleanor?
Why is it particularly active in the Pacific right now?
Well, I think it's just because we have a strong jet, and that begs the question, why is there a strong jet in this part of the globe? And that would be another thing one would have to ask. I don't know the answer to that. But I did see that there's a strong jet oriented exactly along the trajectory of those storms, and that's, I think, the variclinicity on which these things are developing. And it also, though, provides a lot of stretching as these storms try to isolate themselves and become kind of cut-off vortices. They're always fighting the stretching that's provided by the proximity of the jet, because that flow can stretch. And if it stretches too much, it's hard for them to wrap up.
So you think that one that you thought was going to get to, or like that 0C forecast about 937, the jet like was projected to be stronger at like now?
It could be that the jet's a little stronger, or it could be that its interaction with the cyclone is a slightly different type of interaction that prohibits some of the development that we saw on the other one. Although I don't know that, I'm guessing. The question about why does the forecast deviate from one time to the next is fascinating. And these models are sophisticated enough that everything they present in their forecast is a viable animal in the atmosphere. There's nothing fantasy-wise. It's just they don't all verify. So it's fun to compare. Why did this thing do this in that run and it didn't do it in this one? So, but we can't do that just now. Any other comments or questions?
Michael says he really misses being here for this, and he said nice job to us.
Well, I really miss him being here too, and he knows that, so I wish he would make it back, but he's probably gonna serve at least another 4 years, the way it looks like, so that's good. All right, thanks, everybody. Thank you, Pete, for expert driving, as always.